All right, so I think this is recording. Let's take a look at these three problems. They want us, in each of these, they give us two functions, f and g, and they want us to determine if these functions are inverses of each other. So what we're going to do is build the new functions through function composition, f composed with g and g composed with f, and if they are inverses, then the result will be that each of these compositions equals x. So let's jump in on this first one and find f composed with g. So g is the input of f. G is this linear function 3 minus x. F is the linear function x minus 3. So that's what x does. That's what f does to any input, is it takes that input and then it subtracts 3 from it. So here the 3 minus 3 cancels, but we're left with negative x, which is not equal to x. So I claim that these are not inverses. Now let's go ahead and find g composed with f in case one of you had done that first. G composed with f. F is the input of g, and f is x minus 3. G always takes 3 minus the input, and this time we have 6 minus x. And since this is not equal to x, we already concluded that these two functions are not inverses of each other. We need to do the same thing for each of these other pairs. So in the middle here, we find f composed with g. G is the input of f. And g is this linear function x plus 7. F always creates a subtraction problem, takes the input, and then it subtracts 7 from it. This time our input is x plus 7. So this does reduce to x. So I suspect that these will be inverses. Now, the definition says that we have to find the other. We have to find both compositions. F is the input of g. F is this linear function x minus 7. G is the function that it takes the input and adds 7 to it, takes the input and adds 7. This time the input is x minus 7, so that's equal to x. Since both of these are x, we conclude that these two functions are inverses of each other. And you could rename f and call it g inverse, or you could rename g and call it f inverse. Either way. Let's do this last one. So let's find f composed with g. That g is the input of f. G is this linear function 6x minus 2. F will always take the input and create an addition problem. But first it takes 1/6 of that input and then it adds 3. So our input is 6x minus 2. When we distribute, when we take 1/6 of each of these terms, we get 1x minus 1/3 plus 3. So 3 minus 1/3 is 2 2/3, and 2 2/3 would be written as 7/3, right? This is not equal to x, so these are not inverses. Let's find the other way, g composed with f. F is the input for g. F is 1/6 x plus 3. It's a linear function. G always creates a subtraction problem where the first term is 6 times the input, then minus 2. So we take 6 times 1/6 plus 3. So when we multiply these reciprocals together, we just get 1. But 6 times 3 is 18, and 18 minus 2 is 16. And this is not equal to x. So we know that these two functions are not inverses. All right, so I hope that helps, and I'll talk to you later. Bye.